Welcome to Brain Vision.
Okay, in this problem we have a marble on a table. The marble has a mass of 0.1 grams rather. And its position, and the table is 1.75 meters wide. We're first asked to find the maximum uncertainty in its position. From there, find the minimum uncertainty in its velocity. And lastly, we're asked to find what's the uncertainty in the time it takes to fall off the table. So for equations, this is clearly a Heisenberg uncertainty principle problem. And that uncertainty principle is that the product of uncertainties in x, position, and momentum is always going to be greater than or equal to a constant, h bar. And we can combine that with the definition of momentum, mv, to find uncertainties in velocity. The only constant we're going to need to use for this problem is h bar, which is h divided by 2 pi, and that's equal to 1.055 times 10 to the negative 34 joules seconds. So let's jump into it. So to start, the uncertainty in x at its maximum is going to be the size of the table. It can't be any larger. The marble has to be somewhere on the table, so we can state simply that delta x is 1.75 meters. Now to get delta Vx, its velocity, uncertainty and velocity, we can take this uncertainty principle, divide delta x over the other, or rather combine with momentum. Let's do it in 2 steps. Delta x times m delta v sub x. This is just inserting the definition of momentum. This is all going to be equal to, it's all going to be greater than or equal to h bar. Thus, we can isolate the uncertainty in velocity to be h bar over m delta x. So numerically, we will get a result of about 6 times 10 to the negative 33 meters per second. So the uncertainty in the velocity of something the size of a marble is going to be incredibly small. Now to find the time, the uncertainty in time to fall off the table, we can simply take the length scale of the table, x, or rather our delta x. We can divide by this velocity, uncertainty and velocity, because recall you multiply velocity by time, you get a distance. Thus, when you divide a distance by velocity, you get time. So we use the 1.75 meters for the table and the uncertainty in the velocity, which is some incredibly small number. And you can predict that for the time, we're going to have an incredibly large time. So specifically, we're going to have about something close to, not 6. We're going to have something close to 9 times 10 to the 24 years. So this is a gigantic result. And just for some comparison, this will be about, if we know that the age of the universe is 14 times 10 to the 9 years estimated, this will be about 3 times 10 to the 14 times the age of the universe. Wow. So those are the main results. For something the size of a marble with this much mass and a macroscopic uncertainty in the position, we will end up with an incredibly small uncertainty in velocity. Thus, the time will be some inconceivably large number. That's it.